Now that you have your ground truth, it's time to train a detector. Object detection training algorithms fall into two categories: machine learning and deep learning. You don't need to know the details of how these work to decide what to try first. You've got several things to consider, like memory efficiency, execution time for training and detection, and accuracy. Also, how the objects appear in your images. Do they all have the same orientation, or is there a lot of variability? And finally, do you need to detect multiple classes of objects and give them different labels? Machine learning techniques detect one class at a time, tend to be faster, and require less data. The drawback is that they can be less accurate, especially if your objects appear from different viewpoints. Deep learning detectors, on the other hand, are often more accurate and can handle more variability and multiple classes. But they take longer to train and longer to detect. They also require a lot more data and a GPU to keep computation time reasonable. There are always trade-offs. The simplest algorithm will usually be the easiest to implement and the fastest to use. Remember, you could use image processing techniques to find a red ball. If that works, stop there. No ground truth or training needed. Our turtles are more complicated than a red ball. But they don't vary significantly in context. All the turtles are about the same size, color, and facing approximately the same direction. So a machine learning algorithm should accurately find and label them. An ACF, or Aggregated Channel Features object detector, is pretty fast compared to other algorithms and works well on scenes where objects don't change significantly. This machine learning detector uses object edge features aggregated across multiple image scales and color channels to detect a single class of objects. Let's get training.